Ever wondered if it's possible to disappear from one location and reappear in another instantly? This is the tantalizing concept of teleportation, a staple of science fiction that has captivated our imaginations for decades. Its appeal is undeniable. The idea of bypassing the constraints of space and time, of vanishing from one place and popping up in another in the blink of an eye. We've seen it time and time again in our favorite stories. Star Trek's crew beaming up and down alien planets, and Harry Potter and his wizarding comrades apparating to wherever their hearts desire. These tales have made teleportation a household concept, a dream of future technology that could revolutionize our world. Yet as fascinating as these portrayals are, they often leave us wondering, is teleportation merely a figment of our collective creative genius? Or could it one day leap from the pages of fiction and become a tangible reality? But is teleportation purely the stuff of science fiction, or could it become a scientific fact? To tackle this question, you first need to understand what teleportation means scientifically. At its core, teleportation breaks down into two key components, disassembly and reassembly. It's a bit like taking apart a complex jigsaw puzzle and then putting it back together again. But instead of a jigsaw puzzle, imagine an object or even a human being. The first step, disassembly, involves breaking down the object or person at the source location into its most fundamental elements. We're talking about breaking down to the atomic or even subatomic level. This isn't as simple as it sounds. For instance, consider the complexity of the human body with its trillions of cells, each with its own intricate network of molecules and atoms. Now let's move on to the second step, reassembly. This is where the disassembled object or person is put back together at the target location. This process is even more complex than the first, as it requires a perfect understanding of how each atom fits together. It's like putting together an incredibly complex puzzle without a reference image, and where each piece is nearly identical. Add to this the challenge of transporting this information across space instantaneously, and you start to see the monumental task that teleportation presents. Clearly, teleportation isn't as simple as it sounds, but where does our current technology stand? Scene script. Enter the realm of quantum physics, a field that's making teleportation look less like fiction. Picture a world where information zaps instantly from one place to another, no matter the distance. This isn't a sci-fi dream, but a real phenomenon known as quantum entanglement. When two particles are entangled at a quantum level, any change to one particle is instantly mirrored in the other, no matter how far apart they are. This is the cornerstone of quantum teleportation. Yet, don't pack your bags for a trip to Mars just yet. Quantum teleportation is a far cry from the teleportation we see in movies. It's not about zapping physical objects from place to place, rather it's about teleporting information. Scientists have managed to teleport information between particles over considerable distances. In these experiments, the state of one particle is transferred to another, effectively teleporting its information. The original particle isn't physically moved, but its information is. But what does this mean for human teleportation? Currently, it's a concept that's light years away. The complexity of a single human cell dwarfs that of a simple particle, and that's not even considering the billions of cells that make up a human being. So, teleportation exists, but not as we imagine it. The reality is far more intricate and far less tangible than the dream. But who knows, perhaps one day quantum physics will take us where no one has gone before. Oh, with all this in mind, what does the future hold for teleportation? Let's get down to brass tacks. Realizing teleportation as we envision it is a monumental challenge. The first hurdle is the sheer complexity of the human body. Imagine needing to record and transmit the precise state of every single atom in your body, an astronomical number in the ballpark of 7 billion billion billion. Then there's the staggering energy requirement. To teleport even a tiny object, let's say a paperclip, would require more energy than the total produced by humanity in an entire year. Finally, the ethical implications. Would the person arriving at the other end truly be you, or just an exact copy? If the original you is destroyed in the process, is teleportation simply a high-tech method of suicide and cloning? Teleportation, then, remains a fascinating concept. but one that's likely to stay in the realm of science fiction for the foreseeable future.